Let's have a look at a simple example of the maximum flow minimum cut theorem. And I guess it's a bit of a strategy in understanding some of the ideas in networks. If some of the concepts seem complicated, it's always a good idea to try and consider very simple cases first. So the most sort of simplest of networks that you can come up with, or any particular examples that you can have a look at. Try to see if you can understand the concept just using very, very simple networks, and then that can be extended into more complicated networks. So let's have a look at this network here. We have basically just four edges. There's the source, sink. Another word for source and sink is start and finish. And we've got basically two ways to go from source to sink. And let's do part A first. So we're going to determine the maximum flow of this network. We're going to determine it numerically. Okay, we've done this before. And there is a previous set of videos that will look at examples of maximum flow or flow capacity using numerical methods. So let's have a look at part A. Okay, there's two paths, isn't it? We've got path SAT, and we've also got path SBT. Okay, so this is simple enough that you can practically work it out just by looking at it. SAT, really, you've only got a capacity of 1 because SA is really the impediment or the obstruction, really, or the restriction on the flow. AT has greater capacity than SA, but AT is not going to be used to full capacity, so it's only going to be 1. So that saturates this path SAT. SBT, we've got 3 and 4. Its capacity is going to be 3 because BT is not going to be used to its full capacity. Okay, because SB is it's limiting BT because it's only 3. So that gives us a total of a flow of 4. Now let's have a look at it graphically, or using the maximum flow minimum cut theorem, which is a graphical method. And let's cut this network, or let's consider the various cuts that we have. So let's look at sort of the more obvious cuts. So we've got that cut there. Okay, we've got this cut. I might actually use some different colors as well, just so it doesn't get too complicated. But we've got this cut here. Now we've also got this cut this way. Okay, and we also have a cut this way. Okay, so we've got the blue cuts and the green cuts. So okay, so we can see that I might actually label these cuts. Let's call that cut A. Let's call that cut B. Okay, let's call this one cut C and cut D. Okay, so cut A is equal to, now you sum the edges. Okay, so all of these cuts are valid cuts, of course. So each one of them will cut off the source from the sink, so that they'll be isolated from each other. So cut A is 1 plus 3, which equals to 4. Cut B, okay, we've got 2 plus 4, which equals to 6. Likewise, we've got cut C. Okay, you've got 3 plus 2. That's equal to 5. And cut D. Okay, and cut D is, where is it? Yep, 1 plus 4. And that's also equal to 5. So the cut that has the minimum capacity is this one there. So therefore, maximum flow of this network is equal to 4. Okay, so you can actually use either theorem to work it out. Sometimes it's actually easier to work it out numerically than it is to work it out graphically. But either way, it's important to be able to work out the maximum flow using both methods.